Hello everyone. The title of this video is Graph Equations by Plotting Points. In this video I'm going to be doing examples that are taken directly from a free online textbook at openstacks.org, and I'm in the Algebra and Trigonometry text, section 2.1, titled The Rectangular Coordinate Systems and Graphs. And I'm working under the objective heading Graphing Equations by Plotting Points. And each example I'm going to work on in this video is either taken from the examples in the reading of this section or the try it problems from the reading of this section, or from some of the even numbered exercises at the end of this section that are related to this particular objective. I will also have timestamps for when each example begins in the video. I'll have those timestamps in the description of the video below. I also request that when I start a new question, pause the video and try to work it out yourself first before watching me do it and comparing. Because if you're just watching me do these things and not practicing yourself, chances are you're not going to learn all that much. Alright, so I have all the examples written out on paper. So here we go. Again, we are graphing equations by plotting points, right? Remember, points are ordered pairs, an x-coordinate and a y-coordinate on the coordinate plane. So our instructions for all these exercises is to construct a table and graph the equation by plotting points. Okay, so off to the right here, number one, I have the equation involving an x and a y, and you'll see that every equation that I'm going to be doing in this video is going to be a linear equation. Right? And a linear equation in two variables, right, an x and a y, has a graph. Right? When I go to plot all the ordered pairs that satisfy this equation, the graph you will see will form a straight line. And if that's the case, then your equation is a linear equation. Now, of course, in future videos, we're going to see equations that aren't linear, right, whose graphs will not be a straight line. So just please be aware of that not every graph will be a graph of a straight line. Right, but they will be for this video. Alright, so off to the right side, I'm going to make a rough hand drawing. Now, if you have graph paper, that would be wonderful. But I'm going to make a rough hand sketch of the XY coordinate plane, right? So you have a horizontal number line, or the x-axis. So these numbers are the possible values of x in the equation. And then perpendicular to that, right, forming a 90-degree angle with this. And again, I'm just eyeballing it, trying my best to make this look good by hand. You have a vertical number line, right, the y-axis. So on this number line are possible values of the y variable in the equation. Alright, and so now what I'm going to do is I'm going to try to find values of x and y, right, ordered pairs that satisfy the equation, right, that make a true statement. And I'm going to do this by constructing a table where we have, now for the most part, we'll be inputting the horizontal number line variable values. I'm going to input a value of x, and then we're going to calculate what the value of y needs to be in order for the equation to be a true statement. So for this particular text, in this section of this text, they're having you do a 3-column table. 1 column for the value of x that you choose. The second column where you write the equation, so it's y equals, half of x, or 1/2 times x plus 2. And this shows you how to, and you solve for y. You plug in your value of x and you solve for y. Right? And then over on the other side, in the third column, is, all right, what is that value of y? And then you look at the first column and third column for your ordered pair, right? And in fact, I will put a fourth column with the ordered pair that we'll be plotting. All right, you don't have to have this fourth column. And then we'll plot those points on the Cartesian plane. And after plotting enough points, you'll hopefully see enough of a pattern to fill in where the rest of the points are. Right? All these equations with 2 variables should have, infinitely many points, infinitely many solutions. All right, so I'm just going to plot a few, and we'll draw in what looks like the rest of them. Alright, so an easy one would be if x were 0. Right? If x were replaced with 0, you'd have y equals 1/2 times 0 plus 2. Half of 0 plus 2 is 0 plus 2. So y equals 2. Alright, y equals 2. And so the ordered pair, the point I'm going to be plotting is 0 for x. Remember, the x coordinate comes first in the ordered pair. And then 2 for y, right? And then that ordered pair is a solution of this equation. And that's what a graph is, right? Whenever you're asked to graph anything, you're just drawing a picture of the solutions. Right? This is a solution. And I'll go plot that. Now remember how number lines work here. You got 0 in the middle for both of them where they meet at the origin. 0 on the x-axis, and then 2 on the y. So up 2. And I'll plot that point in a different color here. So there's the ordered pair, there's the point, 0, 2. And you can label points if you wish. But that is a solution to this equation. But we can find a bunch more. All right, again, just plug in a value for one variable, solve for the other, and then plot your point. Right, plot that ordered pair. Now, because there's a half here in front of the x, it would be easier to plug in values of x that are multiples of 2. You'll see. Right? So let's say I replace x with 2. So then y would be equal to half of 2 plus 2. Well, half of 2 is 1. 1 plus 2 is 3. So ordered pair has x value 2, comma, y value 3. All right, and let me plot that. So I go to 2 on the x-axis, 3 on the y-axis, and the ordered pair, the point that's in line with both of those, is this point here. All right. 2, 3. Now, you could have plugged in 1. If x were 1, you'd have y equals 1/2 times 1 plus 2, which is 1/2 plus 4 halves. Right? You need a common denominator when you add. That'd be 5 halves, right? 2.5. You could put 2.5, 2.5, 5 halves, all the same number. So x value of 1, y value of 5 halves, or 2.5. So x value of 1, and then a y value of 2.5 would be about here. I'll just put 2.5 because 5 halves won't fit very well there. And here's this ordered pair. X is 1, y is 2.5. There's that point. Right, there's 1, comma 2.5, right, 5 halves. And you see, just from a few points here, you see how all these points seem to be falling on the same straight line, right? As I told you earlier, that all the graphs in this particular video are going to be graphs of linear equations, straight lines. But let me keep going. Let me plug in one more. I'm going to do one more. Alright, I'm going to plug in -2 just to go negative. Plug in -2 for x. Let's see what happens. So y equals 1/2 times -2 plus 2. Now half of -2 is -1, plus 2 is +1. So the point we're plotting has an x coordinate of -2 and a y coordinate of +1. Right, and trying my best here to keep things evenly spaced by hand. Again, if you have graph paper, probably it'll look a little better. But I go to -2 on the x-axis, +1 on the y-axis, and that's this point here. Right. And again, we're seeing this nice pattern. All these points seem to fall on a nice straight line, which once you have enough, you fill in the rest of the pattern. Because there are infinitely many solutions to this equation. Right? We just found 4 of them. You're not going to be able to list infinitely many solutions. So you just plot enough points, you plot enough solutions to where you see the pattern, and then you're going to fill in the rest of that pattern. Right? Fill in the rest of the graph. Right? So following the pattern that these 4 points, these 4 solutions are showing me, the rest of the graph, the rest of the ordered pairs, the rest of the solutions look like they're doing this, right? Going up to the right forever. Put a little arrow to indicate that. And if I kept going this way, plugging in -3, -4, -5 for x, it looks like the y coordinate would keep going down. Right? And again, a little arrow to indicate that. And again, it's a straight line. Looks like a straight line here. Okay, but that's all we're doing. All right, in this video is graphing just linear equations. Unfortunately, right? We'll like I said earlier, in a future video, in future videos, we'll get to other kinds of equations with different looking graphs. Okay, and then now this is a hand drawing, not the greatest looking thing. Let me show you a nice website that'll give you a better looking picture. So you go to, there's a free online graphing calculator called Desmos. It's at desmos.com. And in the box on the left here, I can just enter the equation the way it was given to me. Y equals 1/2 times x, and then plus 2. And then look at this line. Right? It's going up to the right, down to the left, just like in my drawing. Here's the point 0, 2. Here's the point -4, 0. Now I didn't plug in -4, but it would be on there. If you were to plug in -4 for x, you'd get 0 for y. And let's see those other points. Alright, so what I'm going to do is I'm going to go to this little cog here and add a table. And let me show you those points, those same points that I plotted on my paper. Right? I plugged in 0, gave me an output of 2. I plugged in 2, it gave me an output of 3. I plugged in 1, it gave me an output of 2.5. I plugged in -2, it gave me an output of 1. Right? So those 4 points that just showed up, those 4 red points, these are the 4 points that I plotted on my paper. Right? Exactly the same. But it's a lot nicer looking here because you get a nice grid. But please understand that you don't have to plug in integers, right? You can plug in any number you wish for x, 0.75. And, 3 that's this point here, right? 0.75 and 2.375 for the y value. You can plug in, again, you can plug in anything. The square root of 2. I plug in the square root of 2. which is about 1.4 something. Right, so there, 1.414, and then the output's about 2.707, right? That's a rounded number. But yeah, I can plug in pi, right? You can plug in whatever you want. Pi, right? Which is about 3.14, and the output is 3.57 something. Right now 3.14, go to 3.14 here, and there it is. That point there, pi comma something that's around 3.571 for the y value. Right. But yeah, so just be aware that you can plug in whatever you want for one variable and try to find the value of the other one. Right. And then if you're able to, then plot that point and move on. Right. And do it until you see enough points to where you can form a pattern. Right. You can see the pattern forming, and then fill in the rest of the pattern, because it's impossible to plot infinitely many points by yourself, right? You just kind of fill it in, guess where the rest of them are going, but make an educated guess, right? Actually have enough points in there to see the rest of the pattern. Okay, so doing this for the rest of the time. All right, so this next equation, again, we have just y equals, and then some expression with x to the first power. Right, you're going to see again that this is a linear equation. The graph of this will be a graph of a straight line. Y equals -3 times x plus 1. Right, we're trying to find the solutions to this equation, and enough solutions to where we can fill in the rest of them, right? Draw a graph. All right, so once again, I'll do a little rough sketch of the xy coordinate plane. There's the x-axis, and then perpendicular to this. Oops, sorry, my paper kind of folded on me there. There's the y-axis, and yeah, then we'll make a little table. All right, now you can put the 3 columns and whatnot, like I did with the first example. I'm not doing that. I'm just going to kind of speak out loud. When we plug in a certain value for x, what will the value of y have to be? And then I'll put the ordered pair here, right? The x comma y, the point that we're going to plot. All right. So again, easy one to plug in would be 0. Right? If x were 0, -3 times 0 is 0, plus 1, y would have to be 1. Right, so this has the ordered pair 0, 1 on it. So 0 for x, 1 for y, right? That's a point on the y-axis. That's this point right here. And you can label it if you wish, but I'm not going to this time. Right. There's the point, 0, 1. If I plug in 1 for x, -3 times 1 is -3, plus 1 is -2. You'd have y equals -2. So the ordered pair we're plotting here is 1, -2. Right, so 1 for x, 1 on the x-axis, and then -2 on the y-axis. And that's this ordered pair, this point right here. Great, so I got 2 points now. Now, if you already know it's going to be a straight line, 2 points is enough to be able to draw the rest of it. If you want to take a ruler or something, but I'm still going to plot some more. All right. How about this? Let me show you. Again, you don't have to plug in just whole numbers, right? I can plug in a third for x. -3 times 1/3 would be -1, and then plus 1 would be 0. So I have 1/3 for the x, 0 for the y. All right, now here's 0 on the x-axis, here's 1. So I'm going to eyeball 1/3. 1/3, say, is about there. All right, so 1/3 on the x, 0 on the y. So I'm on the x-axis. Right, there's that point there. And again, you're seeing that these points seem to be falling on a straight line, in a straight line pattern. Now let's put a couple more up. How about if I plug in -1? You'd get 4, right? -3 times -1 is +3, plus 1 is 4, y equals 4, right? So we're plotting this ordered pair, right? -1, 4. So -1 on the x, positive 4 on the y, and that would be this point here, right, in line with negative 1 on the x and 4 on the y. Again, this is a rough hand drawing, so it may not look like these are all in a straight line, but they are. They should be. They look pretty close. Alright, and then I'll just do one more. How about plug in 2? Alright, that'd be negative 6 plus 1 is negative 5. Y equals negative 5 if that's the case. X is 2, y is negative 5. So 2 on the x, negative 3, negative 4, negative 5 on the y. And that is this point here. Alright, and then we have, I think, enough points. There's 5 ordered pairs, 5 solutions to this equation. I think we have enough to be able to fill in the rest of the pattern. Alright, it looks like we have a straight line again, right, going down to the right forever and up to the left forever. Right? Again, little arrows on the ends to indicate. But once again, we have a graph of a line, a nice straight line. This is a linear equation. Please know that that's not always going to happen, though. Right? Not every single graph you see is going to be the graph of a line. Alright, just for this video. Alright, let's take a look at this in a better picture, right, on the Desmos site. So once again, the box here, I'll just enter the equation I was given, y equals negative 3x plus 1. Alright, and you see there's 0, 1, which is a point we plotted. Here's, 0.3333, that's 1/3, comma 0, right, which is another point I plotted. And if I go to a table and make a table for this, see a bunch of other points, negative 2, 7, negative 1, 4, that's right here, that's one of the points I plotted. 0, 1, another point, 1, negative 2 is a point I plotted, right? And then 2, negative 5 is another point I plotted. And then we also had the 1/3, 0, right? And those 5 points, and you see the line going through all those 5 points with all the other solutions, right? There's all sorts of other solutions on this graph. Right. Great. Alright, so that looked pretty good compared to my hand drawing. Looks like I did a good job there. Let's continue on doing the same stuff. Right. So third example, another linear equation. And not every linear equation is going to look like this. So far examples 1, 2, 3. In fact, every example I have in this video has y all by itself, right? It's already solved for y. Just please understand that that's not always the case. Now you can solve for y if you wish, right? Perform some steps and get y alone. Maybe that'll make it easier for you to graph. But so here we have y equals negative 2 times x plus 5. All right, so once again, a rough hand sketch over here. If you have graph paper, that would be great. Of the x and y axis. Okay, there's x and y. That doesn't look that great, sorry. And then over here a table, right, with an x. I'm going to plug in a value for x, solve for y, and then the ordered pair we're going to plot, right, the point we're going to plot on the coordinate plane. Now, again, easy one would be plug in 0 for x. Negative 2 times 0 is 0, plus 5 is 5. Y would have to be 5 then. So I'm plotting the point 0, comma 5, right? 0 on the x, and then 5 on the y. Right? So we're on the y-axis with that point there. Okay? And you can label it if you want. If I plug in 1, we'd get 3. All right, negative 2 times 1 is negative 2, plus 5 is 3. Y would have to be 3. So 1, 3. So 1 on the x, 3 on the y. That would be this point here. Then plugging in 2, you get 1. Right? Negative 4 plus 5 is 1. So x value 2, y value 1. So 2 on the x, 1 on the y. That's this point here. And again, after just a few points, you might notice, hey, these look like they're falling on a straight line. Right? But I'll plot a couple more, right? Just a couple more. Plug in 3, you get negative 1. All right, that'd be negative 6 plus 5, which is negative 1. Y would have to be negative 1 for the statement to be true. So you got 3 input, negative 1 output, 3 for x, negative 1 for y. So on the graph here, 3 for x, negative 1 for y. Again, trying to keep things as evenly spaced as I possibly can, so it doesn't throw the graph off too much. Again, looks like they're falling in a straight line. Now let's put one more in. How about I plug in negative 1, right? Let's go negative. Now that'd be a 7, right? This would be positive 2 plus 5, right? Y equals 7. So x is negative 1, y is 7. So negative 1 on the x, 7 on the y, somewhere around here. And again, I think I have enough. I mean, if you already know it's going to be a line based on how the equation looks, then you only need to plot 2 points, right? But you know, I'm definitely seeing a linear pattern here. These are forming a line that's going down to the right and up to the left, like that. Right? Again, that doesn't look very good. It doesn't look very straight, but this should be a line. All right, sorry about the waviness of that. Let's take a look at a better picture. Go back to that Desmos site or a graphing calculator if you have one. I just like this website. Negative 2, y equals negative 2x plus 5, and there it is, right? Got 0, 5, which we plotted. Now this is 2.5, 0. If you plugged in 2.5 for x, you'd get 0 for y. And notice again, you can plug in whatever you want for x, right, and get something for y. It doesn't have to be a whole number. And once again, let's make a little table out of this. And you see some points, right? 0, 5 we had, 1, 3 we had, 2, 1 we had, right? And scrolling up a bit, we had negative 1, 7, right? Plotted a lot of these points. And you can go change the table. You know, I plugged in 3, right? 3, negative 1, and you're seeing right here 3, negative 1 on the graph, and all these other points that form the line. Okay, great. Alright, so let's clear this and move on to our next problem. So far, hopefully, pretty simple. I just got a couple more. Alright, this next one, same setup. Y equals, and then some expression with just, you know, x to the first. So it's going to be another line. You know, both x and y are to the first power, and there are no variables in any denominators anywhere. No other exponents and crap like that. So I know this is going to be a graph of a straight line. Now you can leave it like this, you know, y equals x plus 5 in the numerator divided by 2 in the denominator. But you could also, you know, actually go and divide each of these by 2 and say, you know, x divided by 2 plus, you know, 5 divided by 2. Or, you know, x divided by 2, that's 1/2 x plus, you know, 5 halves. Or if you want decimals, that would be 0.5 times x, right? 1/2 times x plus, and then 5 divided by 2 is 2.5. All these expressions are the same, right? X plus 5 all divided by 2, x divided by 2 plus 5 divided by 2, half x plus 5 halves, 0.5x plus 2.5, all of those are exactly the same. All right, so it depends on what your preference is when you're looking at it. All right, so again, I'm going to make a makeshift hand drawing of the XY coordinate plane as best I can. Again, if you have graph paper, that would be ideal. All right, there's the XY plane, and I'll make a table. All right, I plug in values of x and get values. What does the value of y have to be? And then the point that we're going to plot, right? The ordered pair. Now you don't need this third column if you see them right next to each other. You know, I'm just putting this in for teaching purposes. Okay, now let me tell you right now, based on the way it looks originally, all these ways, since I'm dividing by 2, right? You got this numerator here and then all divided by 2. I'd like my numerator to be an even number just to get nice, because dividing an even number by 2 is nice, right? You end up with a nice integer. And we have plus 5, that's an odd, so I'd like x to be an odd number. Odd plus odd is even. Take an even divided by 2, you get a nice whole number, a nice integer. Right. So I'm going to replace x with some odd numbers. All right, so I'll start with 1. Right. 1 plus 5 is 6. 6 divided by 2 is 3. Y would have to be 3. All right, so I'm going to plot the ordered pair 1, 3. So x coordinate 1, y coordinate 3. And there's this point here. Right? And again, you can label it if you wish. I'm just going to mark the dot. All right, then keeping on plugging in odd numbers, I'm going to plug in 3 for x. 3 plus 5 is 8. Divided by 2 is 4. Y would have to be 4 here. Right? So x value 3, y value 4. So x value 3, y value 4. And here we go. Right? And really, if you know it's going to be a linear equation based on how it looks, that's all you need. You just draw the line through these 2 points. But I'm going to keep going. Let me plug in negative 1, right, another odd number. Negative 1 plus 5 is 4, divided by 2 is 2, right? Y would have to be 2. Y would be equal to 2. So x is negative 1, y is 2. Right, so negative 1 for x, 2 for y. Here we go, around there. And again, it looks like these points are falling on some straight line. And tell you what, I've been plugging in 0 for x for all these. Let's see what happens. If I plug in 0, now 0 is an even number. Right? It's a multiple of 2. It's 2 times 0. So this is going to be a fraction here. 0 plus 5 is 5. 5 divided by 2 is 5 halves, or 2.5. Right? So we have 0 for x, and then 5 halves, or 2.5. Right? So let's, that'd be here, 2.5 on the y-axis. So 0 for x, 2.5 for y. We're on the y-axis. There we go. And again, these points, that's enough, right? That's enough. I know that these all fall on a straight line. Let's just draw that line in here. Right, just go, yep. Going up to the right that way and going down to the left that way. But again, another line, right? Another line, another straight line for all the solutions to this. And once again, let's take a look at a better picture of this on the Desmos site. And just check our answers, verify that the points we plotted are actually on this. So we have y equals, now because the numerator has multiple terms, x plus 5, I'm putting it in parentheses. Right? So we have x plus 5 all divided by 2. And let me go to make a table. And I'm going to plug in the values that I plugged in. We plugged in 1. I plugged in 3. I plugged in negative 1, and I plugged in 0, right, and look, 1, 3, right, that was on our hand drawing. 3, 4, right, 3, 4, that was on our hand drawing. 0, 2.5, 2.5, 5 halves, that was on our hand drawing, and negative 1, 2 was on our hand drawing. So all these, it seems to verify to me that our drawing is pretty good, that the line I drew by hand is actually the correct graph for this particular equation. Wonderful. And you should be, checking your solutions always, right? Just to double check things, make sure you're doing all right. All right, and I got just one more of these, right? Very, very similar, doing the same stuff every single time. So here we have y equals, 4 times x minus 7. So once again, it's an equation where y and x are both to the first power. there aren't any denominators with variables, and there's no special symbols, right? Absolute value, no square root, nothing like that. So I know this is going to be a linear equation. I know this is going to be the graph of a line. Let's see that though. So again, I'm going to make a hand drawing of the xy plane. And once again, if you have graph paper, that would be for the best. Sorry that I don't. And a table. All right, constructing a table here, plugging in values of x and getting values of y. This time I'm not going to put the ordered pair. We'll see them right next to each other. We can see what points we're going to plot. So if x were 0, clearly y would have to be equal to -7. All right, so 0 for x, and then -7 for y. All right, so we're on the y-axis right here. So there's 1 point. If x were 1, 4 minus 7 is -3. You have x is 1, y would have to be -3. So -3 on the y, 1 on the x. So 1, -3, there we go. That point. If x were 2, y would be 1. All right, 8 minus 7, y equals 1. So if x were 2, y would be 1. So 2 on the x, 1 on the y, that's this point here. Alright, and I think that's enough. I already told you, I know this is going to be linear, so really I only needed 2 points, but these 3 points are definitely enough to draw the rest of the solutions in. It's a line going up to the right and down to the left, right? So another line. But yeah, this is all we're doing though. And this just doesn't work for linear equations, right? This is the way you can graph any equations with 2 variables. You plug in a value for one of them, solve for the other, and plot that point. And you just keep doing that until you see a pattern, right? And a discernible pattern. And if that pattern is a straight line, great, linear function. The pattern, patterns might take on like something called a parabola shape, or a V shape, or like a little S shape or something. I don't know. Or, there could be all sorts of shapes. They don't always have to be lines. Right, just please understand that. All right, and I'm hoping that you understood how I plotted all these, and watching these 5 examples helps you in some way when you're asked to plot, some linear equations by plotting points on your own. And thank you very much for watching.